Hello everybody. We're going to talk about some of the common things you're going to see during proofwriting, especially focusing on the given information that's going to come up the most frequently. So I want you to know these are the things you're going to see a lot. If I see midpoint or bisector or parallel lines, this is the conclusion that I should draw. So here's the things that you're going to see the most. First off, vertical angles. So this is one that you can use even if they don't tell you any other information. So just looking at the picture, I can see that there are vertical angles in this picture. Where are the vertical angles? That's these ones right here. So angle ACB and angle ECD. We proved previously that those kinds of angles where you have two lines intersecting, they have to be the same. Okay, so anytime you see that, vertical angles, they're congruent. Okay. Likewise, another thing that you can tell just by looking at the picture is if there's a shared side between the triangles or whatever shapes you're talking about. So in my first set of triangles, there's segment KM. It's in both triangles. KM is congruent to itself. It doesn't change its length when you go to the other triangle. So you can mark that as one congruent side, and we say KM is congruent to KM by the reflexive property. Likewise, in the second set of triangles, WY, this segment right here is literally a side of both triangles, and so we say WY is congruent to YW. It is congruent to itself by the reflexive property. Okay. Now we get into the things where they have to tell you something, okay? Like you need to have this piece of given information in order to use it. You can't make up midpoints wherever you see fit, okay? But like this one, if they tell you D is the midpoint of segment EG, you can make a conclusion off of that. If you have a midpoint, you will have congruent segments. If D is in the middle of EG, then ED is congruent to GD by definition of a midpoint. Likewise, if you see the word bisect, it's kind of like midpoint in the sense that it's splitting something in the middle, right? But you can have a bisector of a segment or a bisector of an angle. And that just means, again, that you're splitting something into two equal pieces, okay? So if this is what they tell you, segment AE bisects segment BD, well, BD is the thing that is being split down the middle, so it is being split into two congruent halves. So BC would be congruent to DC. You could also do that to angles though. So in this one, if it is given to you that segment HJ bisects angle KHL, then you know that there's going to be two congruent angles being made. Basically, angle H is the thing that is being split down the middle. So KHL is the angle up at the top. And if it is being bisected, then those two angles, KHJ and LHJ, must be congruent. If you see an isosceles triangle, that's a word we should know. So if it's given that QRS is isosceles, we know that an isosceles triangle, by definition, has two congruent sides. So in this case, it would be segment QR and segment Q or SQ. And yeah, that's one thing we know about isosceles triangles. The other thing we know about isosceles triangle is that their base angles are congruent. What are the base angles? Well, in this one, if those are the congruent segments, then the base angles are the angles that are across from those congruent segments. And we proved, as I just mentioned, that the base angles of an isosceles triangle are always congruent. So if two sides are the same, then two angles will also be the same. Yeah. Perpendicular, not necessarily followed by the word bisector, although frequently it is, okay? Perpendicular means that it makes right angles. So if you see this symbol or the word, HJ is perpendicular to KL, then you know that there's going to be some right angles in your picture. In ours, it would be angle KJH and angle LJH that are right angles. And if they're both right angles, then it would be reasonable to conclude that they're congruent because they're both 90 degrees, okay? All right angles are congruent. So if you see perpendicular, think right angles. They've got to be the same. Parallel lines, on that note, you can have parallel lines, you can have perpendicular lines. And that also has a symbol that we've seen a few times. The two bars looks like parallel lines. Also, you can see it marked in a picture if you have these little arrows. Those little arrows are meant to indicate that segment RS is parallel to segment TU. They're not necessarily the same length. Those little arrows just mean parallel. And what I know about parallel lines, back in our previous chapter, we talked about all these different kinds of angles that you form with parallel lines and a transversal, especially for our purposes, alternate interior angles. So those are the angles that are inside, but on opposite sides of the transversal. So inside the parallel lines, but on the opposite sides of the transversal, like angle RST and angle UTS, they must be congruent because alternate interior angles formed by parallel lines are congruent. So see parallel, look for alternate interior angles. One more, CPCTC. Everybody's favorite acronym, stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. If you know that two triangles as a whole are congruent, then you know a whole bunch of other stuff has to be congruent between those triangles. Basically, every angle that's in a corresponding position and every side that's in a corresponding position. So usually the way this works out in a proof is maybe throughout the course of a proof, you show that two triangles are congruent, and then you can say that one specific set of sides or one specific set of angles is also congruent. All right, so let's look at a couple of examples of proofs together. Oh, this one's finished. I'm going to pause. Okay, we're going to try this with a slow reveal instead. Okay, so it is given to us that C is the midpoint of AE and segment AB is parallel to segment ED. We want to prove that the two triangles ABC and EDC are congruent. Now, with a two-column proof, almost always I recommend the first things you should do is re-list the given information, just because that's setting your baseline. This is what I know to start with, and then you can build from there. For example, I could next say that, oh, hey, because I know there's a midpoint, because C is the midpoint of AE, then I know that AC is the same length as EC. That's a cool thing to know. After that, well, there's those vertical angles in the middle. Those are pretty cool. We talked about those on our very first page together. I see those vertical angles. I'm going to mark them and I'm going to write about it in my steps over here. And then I still haven't used the fact that AB is parallel to ED. That's these segments right here. And I said parallel lines, that leads to alternate interior angles. And so I will mark angle A is congruent to angle E by the AIP theorem. Alternate interior angles formed by parallel lines are congruent. And so at the end, we can say that these two triangles, they are congruent as a whole because they have the matching parts, angle, side, angle. Seems nice. Okay, let's try this one more time. Whoop. Okay, again, slow reveal. Given that this big triangle as a whole is isosceles, triangle JKL, and knowing that segment KM bisects angle JKL, we want to prove that JMK is congruent to LMK. So these two little triangles up above. Okay, again, start by listing the given information. Seems like the best thing to do. Boop, boop. Okay. After that, what else do I know in this picture? I think I see the reflexive property, don't you? Segment KM is congruent to segment KM. That's this one right here. Oh, good. It's there. Also, because JKL is an isosceles triangle, did I go in the right order? I did. Because JKL is an isosceles triangle, I know that two of its sides are the same. So segment JK is congruent to segment LK. And lastly, I need one more piece because that's only two things so far. Okay, two things. I need three congruent parts between both triangles. I can say that angle JKM is congruent to LKM. That's these two up at the top because of that angle bisector that is mentioned in the given information. And so all things said and done, I do have three congruent parts, a side, an angle, and then another side in both triangles. And so we say JMK is congruent to LMK by side, angle, side. Whoa, how about that? Ask us if you have questions.